I'm just gonna get into it. I don't know if I'll keep the stream on my channel or anything. I don't know how long I'll stream. It's just kind of impromptu, but um, after yesterday's coding stream, I'm just like, you know what? I don't know. I want to keep doing that one. I don't know, I've been feeling a little burnt out recently. So, and well, I also recently started making a voxel game, right? Let me pull that up here. So hopefully it won't take up or lag much, right? This is what I've been working on here lately, past like month or so. So it's literally just this. It was meant originally to be a Minecraft clone, but then I changed it up. I didn't want to just make a Minecraft clone, right? So you have, you know, your seed. You can title the world. You can change this when I add more world types. You enter, and you know, obviously it creates a world. Very slow right now, obviously, because I'm streaming. I hope it doesn't lag the stream or anything. There we go. That's better. We have a debug menu, right? Oceans, you got some shorelines, you got some plains, biomes. And over there, you can see, we fly up a bit, you can see all the dark, oh my goodness, all those darker areas right there are LODs. But I've been trying to change up how my world renders and therefore my LODs. So they're a bit broken right now. They were working better previously. I can probably show you a previous version because I have it all on GitHub in a private repo. Yeah, we move around, it generates chunks and everything. There are unlimited worlds right now. It just generates chunks as you go. It's on the seed, obviously, and that's a different biome right there, technically. It's grassy hills, or windswept hills, whatever, I don't know. Not looking the best, but yeah, that's been my goal a little while, for a little while, right? You get blocks, you can mine, you have dynamic lights by holding another light source, right? You place it. It's nighttime, you can see that, right? You can have a transparent light source block. Other blocks or slabs, kind of, that don't really act as slabs right now. Just like snow layers. And I had normal glass, yeah, right there. Just a normal transparent block. You take down all that. You have a free cam. If I press F4, you can see the world. There's no caves necessarily right now. Let me see if I can pull up another version of the game here on a different branch. Go to change branches. I'm gonna cancel. Alright, I'm gonna commit all to, because why not? It's on its own branch anyways, all the changes that I've been making, because it's a major restructure, so I created a new branch for it. And I'll go there to this branch. Take a little bit. Close all these files I have open there. Let's try to run it. It should work. I mean, they had a lot of errors, but it's just because I changed branches while in a file. Okay, here we go. This is my safety branch, so it should have different things here. Yeah, there we go. This is what I was working on here. much faster, obviously, as you can tell. Um, Different generation, because I've been changing it up as I went along. This isn't my best generation either. You go check my main branch instead of my safety branch. You can see we got some stuff going on there. Same blocks in my inventory. Yeah, that's a bit faster. Anyways, that's what I've been working on for a while, couple months. But I mean, it's not a bad project. I would like to keep working on it, but I feel like it's not up to what I want to do with it. It's like not up to par. So we're just gonna keep. I don't know how I'm gonna work through this. But I want to start some basic projects just to learn. Learn some more. So I created an empty folder. I guess a ray tracer kind of project. There's nothing in it, so I want to start with, CMake. So I want to start some CMake stuff. So I created a new space in my browser here went up the getting started with CMake docs from cmake.org. And I don't know, I kind of want to just learn. I don't know how I'm gonna do it. I'm just gonna try to do something. Okay, so it might not be the most chatty, isn't gonna be the most like, I don't know how to explain it. It's not gonna be like the most it's not a tutorial stream, okay? I just want to start something. Okay. Right, so I know a little bit about CMake. I've used it before for my Vox game I just showed you. And I've used it a couple times in class. But, I just want to really dive a little deeper into it, and a lot of other C++ concepts and all that. Okay. Yeah, I'm just gonna start doing stuff. So, right. So let's just create that. We can open that up. Minimum required version. Forget which version of CMake I have downloaded. So I'm probably not gonna stick to like this here. I probably might just look up what I need to do rather than trying to do their exercises. So let's see. Okay, some lowercase commands are preferred. Make minimum required project. Anything other than this. So typically this is the first line. Okay. Target is a name that a developer gives to a collection of properties. Their collection. Okay. Okay. I don't know. I'm just not really, I'm not a big learner just by reading. Okay, so you know you have executable, right? So first you say the minimum required version of CMake. You define a name for your project here with the project command, and you add your project to an executable. And the target sources properties are like source files we want to build and link. Make current source directory. Okay. This is solution. Okay, well, let's see. How do we want to do this? I define my required or my CMake version. Okay, so we're running 4.3.0 -RC1. Notepad automatically does CMake language for CMake lists. So what was it? To make minimum required version. Version 0.3.0. Okay, you should say that. Project, okay. I'm gonna call it Ray Tracer, like the folder. That's my current CMake so far. Okay, now we need add executable. I believe it's just like that. Right, my program. That's what they put in their project. And target sources. So the paths are source directory. I'm just gonna try what they're doing here. Private, got that, and then we do CXX. Okay. So I think computer should always be private. For executable should always be private. For implementation files. The target building them. Right. There's okay. So let's see, how can we, is it just having a main here? Kind of assuming, but once we have that, I believe to be able to open this folder in Visual Studios. So I opened it there. You can't see it yet, it's on my other monitor. But we have .vs and an out. It says CMake generation failed. So here we are. Let's see output. 3.31 on sync. Okay. I literally just did CMake version. It said 4.3 point something. So apparently maybe this is using a different one. 3.31. Alright, so luckily we can edit CMake directly in our Visual Studio now. So I'm on 3.31.6 MSVDC6, so 3.31. I'm just gonna say 3.31. No, just yeah, whatever. Save it and automatically reloads it or tries to generate it. This is for target private. Okay, let's check here. To do 1, it was right. 2, project, right. Executable. Okay. They have it in another folder. Okay. Let's try that then. I think I want to call this and put this in there. And it would be in this source folder. So that means this is gonna have to be a different. I think it's. I'm not sure. Obviously, that doesn't work. Okay. Well, I'm not gonna lie. Library, header files. You're not a build client. Use a environment. Okay. Describe a collection of header files where you use what's known as a file set. The target source is. Alright. But you wouldn't want to specify every file. Not gonna lie. Not finding the most helpful learning tool here. Let's see. So right. I keep this over here. Oh yes, I might as well use it, like AI to learn. Um, yeah, I might as well use it to learn. I don't know. It's just let's see. Hmm. Right. So targets. So targets represent executables, static libraries, shared libraries, and interface libraries. So like that. Right. So if we're gonna make a structure like this, obviously we need another CMake list in here. And because this will be another module, I'm gonna set it up kind of how I do with my Voxel game here. So we have an SRC and an include folder, and this one also has in it. So we have our header files in here, and then our C++ files in here. So in this one, let's see, we need to. I know we need to add the executable there, because our executable is in this module, so we're gonna define it in this module. Right. So in here, we also need to target our include folder. Okay, so I guess I should define my goal with learning this stuff. I want to be able to know, like my Java projects. I use Gradle, right? But I don't know everything about Gradle. I just know what I need to know to set up my project. And that's how I use CMake. CMake is essentially Gradle, but for, other stuff like a C++ project. So I know in here we can do our target include directories, right? And we use like a public thing, and we could do our CMake current source directory, and then we add our include folder there. This is now we're targeting our source or our include folder there. Right. Okay, and so there's keywords here. So private is only for this target. This target being app. Public is for this target and the dependents. But interface scope is only for dependents. Right, so targeting libraries defines dependencies between modules. The core library. Right. We don't have a core folder yet. Right, okay. So large projects avoid lobbing, which is automatic like scanning apparently. People list their files explicitly? That doesn't seem like it is a good use of time. Right. Of course uses math. Okay. Those in our root, there's compile features, and then they do, well, maybe this is, app is not our root. I'm gonna get this. My best here. This is the root, right? So we want project. We can do more with we can do more with the project. I'm gonna call this like a function. How do they call it? Call these commands. We call them commands. I'm gonna call, we can do more with this command. We could do like a version, and then which languages it uses. Languages. I'm just gonna assume languages works. Okay. So now we have that. we can do some dependencies here. Alright, set up our CMake configuration here. So fire C++ 20. It will fail if it's unsupported on their system. And extensions off. Disables GNU++ 20 forces -std equals C++ 20. But okay. And we will add our subdirectory here, which is app. Right? We made an app subdirectory right here. Alright, that tells it to execute the app's CMake list. And apparently that's it for now. Okay, and then in the app CMake list, they add executable app, right? Which it's executable target without listing its sources yet. Okay, right. So okay. Of course, our target sources for Apple, private, which, okay, as you see, all right, so the target sources. All right, okay. So add our target libraries or include directory section. App. And then we do our relative path. Okay, all this is, pretty self-explanatory. The learning curve for me right now is the commands. Like what command is, what command should I use? That's what I'm mainly looking at. And so we want our includes to be public so that app can use them, and our root, like root can use them too if it needs those, or any other, if I ever make any other modules that can also use apps includes, although this app kind of acts like the main module, and other modules don't typically rely on the main module. It's usually the opposite way around. Okay. It says some projects add that unique export file commands on. Apparently that generates a compile underscore commands.json, which improves like IntelliSense, VS Code, or static analyzers, all that stuff. That's interesting. We'll keep that because that sounds like it's something we would want. We're not done with the app one yet. We have the target and file features. Right. And we set basically the standard for C++ to 20 there. And see, now it's generated, right? So we go to main. Now we can actually start like our project. So I believe something like this. I believe it's the main for C++. Okay, so we need to rather okay, so okay, this is the main class. I'm trying to think we need to do. I know we need like a run loop pretty much. How do I want to structure it, right? Okay. All right. All right. Let's see. We're gonna create another module here. And we're gonna basically copy this one because we can. And this is not that. Right, core. I don't know if we need to target sources in this one. Let's see, and in the root directory, and I know app needs to depend on core. Also, you. No, obviously not. We don't have any. But no, okay. So obviously I don't know what I'm doing quite yet, but okay. There's another recommendation. We can do some about inter-procedural optimization, LTO/IPO. Include those ordered. And this allows the compiler to inline functions across different modules or CPP files. And that sounds really good to me, so. Okay. Procedural optimization. Right. That's good. Okay. Alright, so core module will act as like a library. We're gonna add, instead of that library, static. Here, we'll just restart this file here. Incomplete directories. Okay. So you have to add all the files, right? We'll have that, which means we need to create that file. See. Okay. Now we got another folder for, and we got trace there. A lot to add there. Okay. That. Okay, and it says we can add fast math for the specific library. And then let's see. File options. Otherwise, file options. I assume one of them's for Windows and one of them's for Mac or Linux. Okay. So app. down here we got libraries. Libraries. And we're doing the core, adding to core to it. I already have. Include directories. We can make this private because it seems we could just do back private include. Really, that's right. So what's the issue here? Oh, I said directors again. So that's good. That's done. So a little fast, man. SVC. Right. So if Windows, or if some Microsoft version of C++ or another compile is simulating the Visual C++, the command line syntax. Otherwise, it's like Mac or something. I don't know what I can make out there. Okay. Single instruction, multiple data. Right. So SIMD, single instruction, multiple data, right? So for instance, like a vector 3, when you add two vectors, CPU would add them one at a time, right? X, Y, and Z. But with SIMD, you can add them all in a single clock cycle. Makes it faster, obviously. Okay. So now, just to determine where to where to start exactly. Right. Right. So array is a mathematical function. P of t equals a plus t times b. A is the origin, b is the direction, and t is a step along the line. Makes sense, yeah. Alright. I don't want... So let's say in here, we want to start with how it just automatically like realigns where I'm typing. It's so annoying. Okay, right. So, then we'll have some stuff here later. Okay. Essentially, right, okay, so Pragma once is useful if you have two files, including this header, and they like imagine ray tracer includes common and main includes common. Okay, let's see. Yeah, so if ray tracer and main include common, then the compiler could get confused and say, hey, this class is already defined because, well, also saying main includes ray tracer. So main includes common and ray tracing. It'll say, hey, common is already defined, but Pragma once says, hey, if it's already included, then skip the second time it's trying to be included. That way it doesn't get confused. That's what Pragma once does. It's a header guard. And these are preprocessors, pre-processor directives, handled before the actual compilation starts. Right, so it says literally the preprocessor literally copy pastes code and swaps out text based on your rules. Right, conditional compilation, which is these if statements here. Right, so if using Microsoft Visual Studio, right? If using GCC, Linux, or Erlang, or Clang, I guess, Mac, or LLVM, I don't know what that is, but you know. Otherwise, just finance inline. Right, and so this allows us to write generic code that behaves for the hardware / compiler it's currently on. Right. The core inline macro, that's what this is, a macro. Normally calling a function as overhead, the CPU has to jump to a different part of memory, do the work and jump back, right? Just like in assembly. I've worked in assembly a little bit before for my classes. That's like dealing with a lot of like memory, like manually. You know, instructions like jump to, if you want to like make a function. So you would have like an instruction, and it would say jump to this function here. So you would have to jump to that spot in memory that the function's defined at. And it would run that whatever's in there, and it would jump back to where it was before, and that's overhead. So inline says inline suggests to the compiler to simply copy paste the function's code directly into the spot that it's called. So instead of having to jump to that function and then run it and then jump back, it doesn't have to jump anywhere because it takes the code in the function and puts it right where it's being called. Dead. So it doesn't have to jump spots in memory. And it says here, the problem modern compilers are stubborn. They often ignore inline if they think the function is too big. So this force inline here will force it to go inline. So force inline is specific to Microsoft, and then attribute always inline is specific to GCC and Clang for Mac and Linux. Right. So this is why it matters in like a voxel game. You call like add on a vector billions of times per frame, you can save, like even if you save like a couple nanoseconds, it'll increase FPS because there's less jump instructions and whatever. So that's inline. It's good. And then obviously the namespace, I know about that. Alright. It says we can add, okay, so we can add some common stuff in here. So we can do, we can standardize types, right? We include up here the CSTDInt. We can use different sized data. So like we can use uint 8_t is like is 1 byte, basically 8 bits. So that's why that's where the 8 comes from in uint 8. So we can standardize types here, or rather we can make aliases for uint 8_t so we don't have to type every time. So we can say u8 instead equal to u8 int_t. That way we can just say u8 instead of uint 8_t every time. So that's pretty helpful. See, I didn't know about this till the other day, aliasing, stuff like that. I'm making again u32 UINT32T. I'll even add a U16. That. Pretty neat. We could do F32 is equal to a float. And using F64 double. Alright, that's 8 bytes. 4 bytes for a float. 4 bytes for these as well. So that's pretty cool. Alright. And we can add another namespace here. Math. Const expression of F32 pi. And then we can just paste pi right here. And we can use this should we ever need it. And elsewhere. An epsilon of very tiny number to avoid rounding errors. Alright. That's pretty neat. Alright. Okay, right. And all this makes sense to me. Okay. So what if I want okay. Template specialization. Alright, strategy, write the logic once, specialize the data. Base template. Math operators, yeah. Alright, so we're gonna create, I'm gonna add folder here. We're gonna add a vector TP here. Include our common. I believe I want to say I doubt that this is including. We need to do anything in here. I don't think so. We'll see. We can include CMath, and we can include the assert. Ray tracer math is our namespace. Alright. We do a core inline. I don't think so, because it might not have worked. Really cache and configure. Yeah. I want to make sure that we're able to include our stuff here. work? No. Hmm. Hmm. That might be it. Still doesn't seem to recognize it. Being annoying here. Hmm. Okay. What's wrong here? Don't think. Oh. Hmm. Eh. Let's just see what happens. Alright. My goal is to do. Okay. Right. I don't like it to just, to just work. IntelliSense, at least I don't know if it's a pile or not, but God, I hate it. Why can't you highlight? For example, probably because of this. Why doesn't this work? Forward slash. That shouldn't be like, it shouldn't be like this. Alright, time to look at my other project. Just see what it looks like here. Okay, so instead of this, let me try this. Public. It should be just starting from. It should just be starting from here. That should be the include, not this whole string. Already. What the hell are you talking about? We need to make that. Make it like that. Quotes. Let's. Nope. It's still telling me to do. Why is it starting here? Alright, let's just say include 4. Like that. It's still starting here. Why is it starting here? Why is this? I don't understand why it's starting there. Shouldn't be. Doesn't work. Need to. Guys, you can delete and recache. Nope, that's still. Mm. God, dude. Alright. This is why I hate AI when you're not on a more advanced model. It's just telling you the same thing over and over. Oh my god. AI is just literally stupid if you're not on a more advanced module. Or advanced model. Alright. Okay. Mm-mm. Mm. Oh, God, I hate it. I get it. Absolutely hate it. Why are we doing all this stuff? It should just work. It should just work. Hello. Welcome in. I don't really know what I'm doing with stuff. Mm. Yeah. Mm. now it ran. I don't see anything in build. There we go. File commands. Okay, let's try this again. Oh my god. Want it to include correctly. Let's try rebuild all. No. Budget. Delete cache. Reconfigure. No. It doesn't like working. Alright, I'm gonna open this in terminal then. No, doesn't. I feel like it just doesn't, like, why doesn't it work? I don't know. There's a solution file generated though. I'm gonna close this then. Open the solution instead, I guess. Like this. There's no header files in here. Hmm. Hmm. Oh my gosh. Dogs are barking. We're gonna try doing all that then. Now, this means how can you not find the source files? You know what? Gosh. It's a hassle. Oh my god. How could you not find the source file? know. I think it just, I don't know why. I think it doesn't like using math or something in the path. Good. God. Jeez. How you doing, Cottage? Okay, you know what? I can't sing. You know what? I've been streaming hour and a half. I might end stream pretty shortly. Might do a game. I'm hungry. I might end stream, do a game stream later or something. A little bit later after I eat. I think I'm just gonna keep trying stuff later because I want to learn all these like professional, more like advanced sort of C++ stuff. So I might just try to keep doing that offline. I don't know. But yeah. Do you wanna do a? I don't know if you stream, if you're planning on streaming today. But yeah, I might do a game later. If there's like a multiplayer game or anything, hit me up. Something. Okay. Yeah, I think I'm gonna end it here. Thanks for tuning in. Anyone who tuned in, and Cottage. I didn't really. I intentionally didn't put any. I didn't. Okay, cool. Yeah, I intentionally didn't post the link to this stream in any Discord channels or servers, because I didn't know what I was gonna do for it, to be honest. Like, I knew what I wanted to do, but not how I was gonna do it, I guess. Pop up in the center here. Yeah, yeah, plans this weekend, it would probably have to be Saturday then, right? Because Sunday's Easter. Yeah. On You know, it just, yeah, you can let me know the details later. I guess I'll probably be around, most likely. But yeah, I haven't streamed with anyone in a while. um, yeah, figure something out. All right, end here. I'm not gonna go on a ramble about all the usual end stream stuff because I don't even know if I'm gonna keep this one up. To be honest, we'll see. It's still something. Stay around. Thanks for tuning in and chatting. Also, have a good one.